Okay, so we're back. Start here. Let's go ahead and take a look at the answers to this problem. So again, you had 300 people, and you are always going to get, for your expected, either a percentage, and you take that percentage and you multiply it by n to get your expecteds, or they'll say equally likely, and then you take 300 and divide them all equally amongst the groups, the categories you have. So that's always going to be the case. Okay, so again, I'll say it again. Your observed are just going to be written out for you and given to you. You write those in. The expecteds, you're either going to be given a percentage, and you take that percentage and you multiply it by your n to find your expecteds, right, NP, or you'll be told all equally likely, in which case you just take your n and divide it equally amongst all the categories. So here, we had 60% were reusable, so NP, 300 times 60%, 0.60, and then we had for plastic 32%, so 0.32 times 300, and then the last one, paper, 0.08. And don't make this mistake because it will mess you up in all your numbers. 8% is 8 cents, 0.08, not 0.8. It will totally give you the wrong numbers otherwise, and you'll be totally messed up. All right. H naught is O sub I equals E sub I. H1 is O sub I is not equal to E sub I. Critical value. So we have three categories. 3 minus 1 is 2. Alpha is 0.01. So we're going to go over to our handy dandy chi-square table, and degrees of freedom 2. Alpha is 0.01, and it's 9.210. So there it is there. So I'm going to do my little straight up and then swoop off, 9.210, and shade. That's my critical value. Then my chi-squared, it's so easy just to do this. I mean, it's so easy to do this by hand, right? It's just 152 minus 180 squared just from your table, right? Divided by 180. 120 minus 96 squared over 96. 28 minus 24 squared over 24. And then just calculate those. So I found them each individually in my calculator, wrote them down, and then just added them up. You have to, on the exam, you have to show me this part here encircled and the answer. You don't have to do this intermediate step if you don't want to, but you have to give me all the numbers, you know, this minus this squared over this, plus this minus this squared over this, and then the final answer. And then pop it into your slot here. And that's totally in the guilty area, so reject H naught. So then we do have enough evidence to reject the claim that the proportions are as stated. That's the minimum you need to do. You could be fancier about it and read through the actual claim. On the exam, it's just going to be something simple and straightforward like that. On your homework, it'll be a little bit different. They might give you something fancier or more unusual. But that's, you know, you can kind of work with that.
Professor Young, again, for this problem, H1 is the claim, isn't it?
You can make an argument either way. Are they claiming that it differs, or are they claiming the same and asking if it differs? It's kind of hard to say which one it is that they, you know, they're.
Yeah, that's what I thought.
Yeah.
It's a little bit confused in that sense.
Yeah. But again, for the exam, you can just assume the claim is always that they're equal. The proportions are this, and it's either true or not true. And here it's not true because we're way out here. Okay. So now we're going to move to 11.2. So go to your 11.2, flip the page, and go to 11.2, which is test using contingency tables, two-way frequency table. Looks kind of like this. Look at my little spot in the corner. This first page is all the information you need. You guys are going to ask me later how to find the critical value and degrees of freedom, and it's right down there, about 2/3 down the page. It says critical values. So you're going to need that information. It's going to get, and it gives it to you right there. Test stat, all that stuff. It's right in that bottom third. Okay. So first of all, Yes. First of all, test of independence. It tests to see if the rows and columns are independent from each other. Homogeneity of proportions. Test to see whether the proportions are the same. Those are the same tests. Because if your proportions are equal, homogeneous, the same, then your variables are independent. They are basically the exact same test. And we use just that one chi-square test for it, for both of them. So you might say, well, what's a contingency table? You've worked with them before in Chapter 4. Contingency tables are those two-way tables. Remember the puppies in the pound or the shelter, right? The labs in the shelter. We had chocolate labs, black labs, and yellow labs, and we had male and female. That's a contingency table. It's when you have one variable for the rows and a second variable for the columns. So along the rows and columns, so Chapter 10 we had two variables also, but they were numeric variables. They had numbers as answers, like casino size and casino income. Those are all numbers. These ones are going to be categories. So our variables are going to be like, what type of lab is it? Chocolate, yellow, black. What gender is the dog? Male, female. It's going to be things like that, where your data is going to be categories, and you're going to just keep a tally of them, as opposed to your data being numbers. So we'll show you an example here. So here's one variable. The variable is, what was the outcome of your surgery or your treatment? And then here is, the other variable is, what was your treatment? Right, so I broke my foot. Either I had surgery, or I had a weight-bearing cast, a non-weight-bearing cast for 6 weeks, or a non-weight-bearing cast for less than 6 weeks. And whether it was a success or failure will pop you into one of these slots here. Right? Similarly, say my neighbor, she has a black lab. His name is Smokey. He's a male. So he's going to be one of these. He's going to be counted in this number here. That's Smokey's spot. So if you guys remember back to Chapter 4, which hopefully you remember because it's coming up on the final again, if two characteristics are independent, then that means that the proportions are the same. So here we have our black labs and male labs. Are they independent? You take your black male labs, and you take your total of your black labs and total of your male labs and your total, and then you make this ratio, 13 over 23 to 25 over 40, and you see if they're the same. So is 13 over 23 the same as 25 over 40? No, they're not. So these are dependent. So being a black lab depends upon whether you're male or female. You'll get a different answer. So that means that these are not independent because the proportions are not the same. And this was for one specific thing, male versus black, black labs and male labs. But this whole test that we're doing now is for the whole thing, are the types of lab, all of them, independent of whether they're male and female, their gender. So we're going to look at every single ratio. So 5 to 8, 5/8 to 5, is that the same as 15 to 24, 15/24? So is that the same as for yellow, 10 over 16? So the same as your total, 30 over 45. Are these proportions all the same? In this case, they are. They're all equal to 0.625. I don't know why the left side got left out somehow. So that's the question. Are all the proportions the same, equal? In other words, are the proportions homogeneous? And if they are, then they're independent. Then we would say that gender and color are independent of each other. Now we know that even if they are exactly the same, that if we sample, we're never going to get exactly that many. It's going to be off a little bit, right? We might get 4 male labs, chocolate labs, and we might get 4 female chocolate labs, and we might get 16 black labs, and we might get only 9 yellow labs or something like that. So it might be off a little bit, but the question is, are they off? Are they off an acceptable amount where it's not that big a deal where it's still pretty close, or are they off some crazy amount and it's not at all the same? And that's what this test is all about, is seeing if these proportions are close enough to be the same. Okay, so here's some notation which is totally familiar. O, your observed frequencies. E, your expected frequencies. Again, O is the one you get, were given to you, and expected is the one you calculate. And then R represents the number of rows. In other words, the ones going across. These are rows here, right, going across. C is the number of columns. So columns go up and down, like this, right? Don't include the labels. All right, so here's our basic test. H0 is, again, no. In this case, no relationship. Also, no difference. They're equal. So the first proportion is equal to the second, is equal to the third, is equal to the fourth. There's no relationship. Or you could just go to generic O sub I equals E sub I. I'll let you slide on that. That's fine, because you've got enough confusing, crazy things to think about this chapter, and we're coming to the end of the semester. Let's just make sure you pick this up and get this down. So you can just use this, the observed equal to the expected. That's totally fine. H1 would be the opposite of that, right? Instead of no relationship, it would be there is a relationship. And instead of them being equal, then at least one differs. And instead of these two being equal, we're going to say O sub I is not equal to E sub I. So that's H1. It can be any one of those. You can just do the simple one here of O sub I equals E sub I, and O sub I is not equal to E sub I. That's totally fine. You'll get full points on the exam for that. Again, your homework will be tougher than that, and you're just going to have to roll with it and figure it out and kind of read through it. It's very straightforward, actually. It's very logical. You just have to take the time to think it through and logic that part out. Okay. In order to test it, again, we're going to assume the null hypothesis is true and create a contingency table. That table that has a bunch of numbers in it. That's kind of like a square rectangle. Degrees of freedom is rows minus 1 times columns minus 1. R minus 1 in parentheses times C minus 1. So again, if you look on your sheet here, guys, everyone pay attention. On your sheet here, it's right there, about 2/3 of the way down. Degrees of freedom, you're going to use your chi-square table, and degrees of freedom of R minus 1 times C minus 1. Your number of rows minus 1 times your number of columns minus 1. And then the formula is exactly the same, right? Your O minus E squared over E, and then you add them all up. You do that for each category, add them all up. And then we also have our expected frequency, which is our row sum times our column sum over the grand total, which we're going to talk about in just a couple of slides. But first, right, so you'll need to be able to compute your expecteds, but then I'm going to let you use and you'll have to compute the first one and the last one by hand. But then you can use your TI calculator to do everything else. So this one's going to be a lot easier than 11.2 because you can just use your calculator, put it into a matrix, run a test, and you got your numbers. So it's going to be super straightforward. This one, everything we're doing today is actually going to be really easy in that sense. So to do it, we're going to put our data into matrix A. So matrix is when it has this little square box here like that. You can see the little squares around it. That's matrix A. And then we're going to do stat test chi-square test on A, comma, and A and then B. What that means is that we've put everything into A, and then it's going to calculate things and throw the expected, it's going to calculate the expected for you and put that into B. It's going to store that into B for you. Right? This will output it to B. So B could have any garbage in it, and it's going to overwrite B and put in what the new expecteds are for your A. Right? And then when you do it, it's also going to give you the chi-squared value and the p value, both. The two things that you need. All right, so here's an example. Okay, so everybody take a look at this one and tell me how many rows and how many columns we have. Private chat it. And again, the null is not always the claim for the homework. It's going to vary, like Gina was saying. But for my exam, the null is always going to be the claim. Is this a late chat? Is my chat Old. Oh, this isn't. Oh, that's from last class. That's why. Oh, good. You guys are telling me. How many rows? How many columns? Private chat it. I've only heard from 4 people so far. 5 people. 6 people. 7. Oops, that's a repeat. 6. 6 people. I'm waiting for more. There's 17 of you guys. We can wait here for a long time. Get your chats in. Prob, Ria, Megan. What else I have not heard from? Jay, did I hear from you yet? Eva. Oh, Eva's here.
I thought I sent it.
Ashley. Ruby. Well, maybe that many of you. Okay. So there are 3 rows. So you cannot count. These are totals. These are also totals. Don't count the totals. And this is the grand total. You can only count the actual data. So surgical site, pneumonia infections, surgical bloodstream infections, total is not a category. So you'll have 3 categories, and then you'll have 3 hospitals, A, B, and C. So this is a 3 by 3. 3 by 3. And again, remember it goes row. Why is this not writing? 3 by 3, row, column. So think RC Cola or RC, anything you want to do, Royal Caribbean, whatever you want that works for you. But RC is how it's right. So the first one's the R, the second one's the C. I remembered it when I was a kid. When I learned it, I remembered just because it was RC Cola, because there was a big thing when I was growing up. Okay, so rows and columns. We have 3 rows, we have 3 columns. Obviously when it's square it doesn't matter, but when you have an uneven amount, if they're different, then it does matter. And so our step 1 is going to be H naught. You could just put O sub I equals E sub I, but they put number of infections is independent of the hospital, and then H1 is the number of infections is dependent on the hospital, or it's related. So in this case, if you get a homework problem like this, it's going to want you to choose H1. In this case, H1 would be your claim. So for the homework, the claim could be either. But for, like I said, for the exam, it's always going to be H naught for me. But just be aware, it might give you something like this on the homework, in which case H1 would be the claim here. But if you just write O sub I equals E sub I to the top, and O sub I is not equal to E sub I right now, that's fine, and you'll get full points on the exam. Then find my critical value. Okay, let's see, I have 3 rows, so 3 minus 1, 3 columns, 3 minus 1, because remember this is R minus 1 times, right, this is parentheses R minus 1 times C minus 1. So that's where that comes from. And you will get 2 times 2 is 4. So 4 degrees of freedom. Go to your table. I have my table here. Nope. Go to your table. We actually looked at it before. We get 9.488. So draw your little chi-squared thing straight up, flips out, 9.488, and shade. So you guys should have done that at this point. And again, you could just write O sub I equals E sub I here. That's fine. O sub I is not equal to E sub I. That's totally all right. Okay, moving on. So this is, you guys are filling it out. This is our example at the very top of the next page that you guys are filling out. Steps 1, step 2. And we're going to move on to step 3. So you have to find your, maybe I'll do this one with you guys. That might be better. Let me go ahead and grab it. we need to find our expected so what we need to do is all right, let's see. We've got it's smaller. Hold on a second here. Great. Okay. Okay. So let's take a look at the first one. He has a row sum. So he's in the first row. So 119 is his row sum. He's in the first column. So 246 is his column sum. So his E11, I'm going to write like this, E1, comma 1 is going to be the row sum, 119, times the column sum, 246, divided by the grand sum of 582. You need to find the first and the last. This is E11 because it's the first row, first column. You also need to find the last one. So the last one is this guy here. Remember, don't count the totals in your data. This is my data here. So this one here, he has a row sum of 384, column sum of 200. So that's going to be E, let's see, he is the third row, and he is the third column. So that's going to be 384 times 200 divided by 582. So that's going to be my expected value for that last one. You have to find it for the first and the last. My first time I taught this, I made it find them for all 9 of them, and then do everything by hand, all the calculations by hand. Obviously, things have changed since then. I've been convinced that that is not necessary. So you guys do not have to do that. But you do have to find the first and the last. Only the first and the last, but you do have to find the first and the last. Good? Theoretically, you should find all of them. But I just want you to be able to prove you know how to find it. So just the first and the last one's good enough. That'll work. And again, I would say 3 sig figs. Okay. Everybody on board with this part? How to find the first and last expected? So this is all of them, and again, you only need to find the first one and the last one. There they are, prettier. And here they are next to their respective amounts. So we're comparing 41 to 50.3. So normally we would do 41 minus 50.30 squared divided by 50.30 plus 27 minus 27.81 squared divided by 27.81 and so forth, and add up all 9 of these. And if you did, it looked like this. And you get 30.698. That is our chi-squared. You do not have to write these down, and you do not have to write out all 9 of them at all. So like for the previous one, hold on, let me go back. So for 11.1, you have to write them all in there. This minus this squared divided by that. For chapter 11.2, you don't, because there's just too many of them. Right? The other one's only going to be 3 or 4, so I don't mind forcing you to write that down, but then you've proven you know the formula, which is the same one as this formula, so you do not have to do it again for 11.2, just for 11.1 on the exams. Instead, we're going to take this matrix and we're going to put it into a calculator. So you're going to matrix, edit, A, and then put in your number of rows and number of columns. So I'll show you. Everyone bust out your calculators, get them out, pull them out. Okay. Everybody have your calculators out? Turn it on. We're going to do, we want a matrix. This is a matrix, right? It looks like a square or a rectangle. So we're going to do second, and then matrix, which is the fourth one down right here, where it says x squared. That's you see in blue it says matrix on it. So blue and then matrix, and you get this. Again, second matrix, fourth one down, you'll get this. Go over to edit. We're going to edit it. And we want A. That's great. First one's A. Perfect. Hit enter. Now, I want a 3 by 3. So this is a 2 by 3. So I'm going to put in 3 here. And as I go overlook it, it's going to add in 3, make 3 rows. And then I want 3 here. So I'm going to put that in there. If I wanted a 1 by 1, I would arrow up 1 by 1. And it'll give me a 1 by 1. Again, you can arrow up to change that if you've made a mistake, because some of you guys will make a mistake and do your columns first before your rows. Okay, now put in your data. 41, and you'll notice if I hit enter, it goes across. 27, enter, 51, enter, and then it goes down to the next row. 36, 3, 40, 169, 106, 109. Then double check. Last class I had a typo, and you don't know if you have a typo when you're typing it, right? You got to double check it, because if you don't, everything's going to be wrong, and you have no idea. So that looks right. Looks good. Great. So even if you don't have them in yet, stop and look what I'm going to do, okay? Just watch me. Even if you're not done yet, just watch. Now I have it in stat. Go over to tests, and go up to chi-squared test. This one right here. Not the goodness of fit test, the chi-squared. 83s won't have that. 83s only have this chi-squared test. So that's why we're using that one. And then observed A, which should be in there. That's what you just put in. B's, the expected, that's where it's going to calculate your expected and put them there. Hit calculate, and it's going to give you, boom, there's your chi-squared. 30.696, just like we found on the previous slide. And then here's my p-value and degrees of freedom. You guys take a look quick. One thing, degrees of freedom, you can double check to make sure you got it right, because it'll calculate that for you. But also look at my p-value. Is my p-value 3.53? Private chat me, is my p-value 3.53? I'm waiting on everybody. Is my p-value 3.53? I've heard from one person. 2 people. Is my p-value 3.53? Who's here? I'll do a quick roll call. Okay. So 6 people are here. It's right here. It's written right here. So p-value is what you calculate in your calculator. Okay, so here's the deal. Here's my matrix again, right? Here's the test, chi-squared test. Again, this is what you input, and then this is the one that it calculates. But your p-value cannot be 353%. 3.53 is 353%. That's over 100%. You can't have over 100% chance. Whenever you have a number larger than 1 here, look for the E negative something. It's always going to be there. It has to be there. It has to. So this means put, for p-values, if you have a number larger than 1, there better be an E negative something. So you're going to put, this means -6, put 6 zeros, and then 353. Decimal place goes after the first 0. That's how you do that one. Okay, so don't fall into that trap, because you guys are going to have that problem come up. So this is really small, super small p-value, super unlikely. We're totally going to reject H0. We know ahead of time, because that's way less than 5%, less than 1%. Okay, so here, because our p-value was 30.696, okay, that's, well, some large number, way more than 9.488, we're going to reject H naught. Do you guys want to see that again on the calculator, how to get to the matrix, or yes? Yes, no? Everybody good? One more time?
One more time.
Okay, sure. All right, so second, and then the fourth one down is the one that says matrix in blue, so we hit that one. And then go over to edit, right arrow over to edit, and then pick A. Just pick the first one, enter. Change it to what you want. We want a 3 by 3. You can make it into a 2 by 2 if you want, or a 2 by 1, or a 3 by 6, whatever. And then just type it in, and then hit enter, and then go in and type in your numbers. When you're done typing them in, you're going to hit stat, and just to get to the next one, you can either arrow, or you can hit enter, and it'll move you, enter will kind of move you off to the right and wind you across. Stat, when you're done, stat, test, and then go up, because it's towards the bottom. Chi-squared test, right there. Hit enter, and your printer's going to leave it alone. Observed is A, expected is B, matrix A, matrix B, and then calculate. And there you go. There's your chi-squared. There's your p-value with the e -6, so super small, and then degrees of freedom is 4. Why is degrees of freedom 4? Because I have 3 rows, and I have 3 columns. So 3 minus 1 is 2. 3 minus 1 is 2. 2 times 2 is 4. And then the last step, we do have enough evidence to reject the claim that proportions are as stated, or you can be fancy and do this one up here. Either one's fine with me. Your homework may require the fancier one, but I'm good with the bottom one. So go ahead and write one of those in, or both of those in. Okay. Go and take a picture if you haven't, because I'm going to close this up in 5 seconds. 5, 4, 3, 2, 1. Okay. One thing to note is that a large chi-squared value goes with a small p-value, right? As we get further out here, it's just like the chapter 8 as well. As you have a really large critical value, that means that you're really unlikely. Your p-value becomes really small. Remember, the p-value is the probability of getting a sample like yours. If you have a small chi-squared value, then you have a large p-value. But yeah, so one way that somebody said that they remembered it, and I think she got it from the book, was yeah, if p is low, H naught must go. In other words, we're going to kick it out and reject it. I kind of like that. That's kind of neat. So at any rate, so that's kind of one thing to kind of remember if you're having trouble with it. And why don't you guys go ahead and work on the next problem. But before you do, let me ask you this real quick. Everyone take a look at lab problem number 2, sports preference, and take 15 seconds, stare at it, like literally pay attention now. 15 seconds, guys, wake up. How many rows and how many columns does it have? Figure that out. How many rows, how many columns? Okay, so there are, look at the data, male, female, football, baseball, hockey. So 2 categories there, 3 categories there. So it's a 2 by 3. 2 by 3. Remember, it's R by C. So 2 by 3 row column, male, female, 3 across. All right, go ahead and hop into your groups.